AICUG, Artificial Intelligence Core User Group, is a non-profit organization which was established in March 2018 with the purpose of spreading AI knowledge in order to help people to learn, understand, and develop AI technologies by providing multiple services for the community, including tech meetups, conferences, closed-door meetings, online courses and talks, etc. The event I assisted was When Data Meets AI, developing and managing predictive apps and data with machine learning. Machine learning is used to teach machines how to handle the data more efficiently. 1. The purpose of machine learning is to learn from the data. Many studies have been done on how to make machines learn by themselves. 2. 3. Most machine learning projects fail to go beyond the data scientist or researcher. This because their implementations hit a wall when they try to operationalize the ML models into enterprise production IT environments and integrate ML into mainstream applications. Open source programs such as Python and R are great for developers to build applications, but the integration of ML layering is difficult. This meetup presented how to eliminate the division between developers and data scientists when the ML algorithms are part of the enterprise data management application development platform. The audience of the event was mostly professionals from different backgrounds, not only data scientists or researchers. I met people from healthcare, finance and banking, technology, and students of graduate school from computer science. With the abundance of datasets available, the demand for machine learning is rising exponentially. Nowadays, many industries and businesses are applying machine learning to extract relevant information. Some examples are medicine, military, chain supply, and retail. I had the opportunity to meet a couple of students from San Jose State University with whom I had the chance to interchange ideas about machine learning concepts. The easy accessibility of free machine learning libraries has made all kind of professionals and business interested in this new technology that previously were difficult to access due to high costs and little industry knowledge. Sandesh Rao, VP, Oracle Autonomous Health and Machine Learning Oracle Corporation, explained that Oracle made possible this integration by moving algorithms to the data and development. Oracle has extended the Oracle database, autonomous transaction processing, and big data platforms into hybrid data management and machine learning platforms for the developers. CX Oracle Python interface for Oracle Database enables connectivity to Oracle Database connecting and underlying Oracle client libraries using and managing Python scripts and Python objects in Oracle databases, producing better and faster models with automated machine learning through the possibility of translating functionality to SQL using familiar Python syntax to manipulate database data. In general, the ideas and common conclusion between assistants and speakers were that the fundamental and most time-consuming part in machine learning is the data modeling and data conditioning in order to choose the correct attributes in order to train and test different machine learning models. Overall, I had a gratifying experience. Having assisted in this meeting reinforced all knowledge related to data science and programming courses I am taking at ITU. I highly encourage the university to keep encouraging students to assist with this kind of meetups, where networking is a fundamental part in order to reach professional and academic goals.
I'm doing a linear regression. That's the model that I'm printing. So I'm doing LM. Then I'm trying to take petal and petal width and length. Remember I told you the iris data set. Iris data set has petal width and petal length as two of the values. I take that as the X and the Y value. I do a fit. So basically using petal length, I'm trying to predict using petal width, I'm trying to predict petal length. I fit. LM again is the model, the algorithm, dot fit XY, input data, predicting value of Y, what you're trying to predict as the Y, and then you return the LM. Here, I read the table, which is the iris data set, and then here I apply the thing, and I take petal length, petal width, and species as the input. I do an index on it, and I use this function, build underscore LM here as input, and then I sort the values when I pull them out. All this data for the iris data set is sitting in a backend Oracle table. It's that simple. Meaningful clusters, and then you will switch to either a supervised or semi-supervised approach on those data patterns that you once identified. Like here's an example, right? If I were to give you flower data and you not know what to do with it, you pass it, it will basically say, this looks like flower data. And then it will tell you, these are the attributes, and this is the feature reduction I can perform, and these are the labels. And then you can specifically design your model to look at that data in that fashion.
Makes sense.
So that's why, this whole unsupervised learning space is sort of like an exploratory action that gives you patterns of what you can do with this data. You can actually use certain forward or back propagation parameters to be able to say, okay, based on this, this is what you should be doing. But those neural networks are extremely hard to train. They're very sensitive to data aberrations. As a result of which, you should only use neural networks truly for applications that neural networks can handle. So text-to-speech, translation algorithms, facial recognition, image recognition are classic examples where you can do this. For anomaly detection, most use and picking the right attributes is the key success to a machine learning project.
Say that one more time.
The different combinations of these algorithms with different hyperparameter values with the right attributions picked in the data are the defining factors for a success in a machine learning exercise. Okay? Now it all sounds complicated, but there are automated frameworks for this. In the open source space, in the Oracle space, it's kind of everywhere. Then there's obviously neural network and deep learning. We won't be concentrating too much on this because I don't think we have time to talk about all this. All these things here, these are all regression algorithms. There's lasso, there's random forest, ridge regressions. Each of these, they work better with different kinds of data. Okay? An example is, if you're using SVM, there's something called an SVM1 classifier, which we have built into Oracle. It is used for trying to predict anomalies. And when you're passing, say, CPU data or health data, you can predict whether this thing is going to fail or not. That's one of the algorithms for that. Identify the right frameworks that have the right algorithms to apply for this. Thank you guys, and have a wonderful day.